All right, let's get started with 0.5, rational expressions. So we are going to cover 3 skill objectives here. We're going to find the domain of an algebraic expression. We'll reduce it to its lowest terms, and then we'll multiply and divide multiple ones. We are not going to be adding or subtracting. We are not going to be simplifying complex rational expressions. So take those off your plate. All right, so big takeaways: understand why rational expressions have domain restrictions, and we'll understand the least common denominator method. You know what, actually, that's for adding and subtracting. No need for that one, so we'll get rid of that one. So one big takeaway: why do we have domain restrictions? All right, so just a reminder, rational expressions are quotients of polynomials. Not a reminder, we haven't said this yet, but this will be in your summary of everything. So just like 1 over 2 is rational, if we add in some variables, that becomes a rational expression. So rational expression, just variables in the denominator. So we could add things like this, 5 over 3x, things like that. So anytime you have a variable in the denominator, we're talking about a rational expression. All right. And then just 2 quick reminders: when you're multiplying fractions, you multiply top times top. 2 times 3x is 6x. And you would multiply bottom times bottom. So in this case, x plus 1 times x minus 1 is x squared minus 1. We just went through that with our factoring and multiplying polynomial units. Okay. Now we'll talk about domain restrictions in a second. And then when you're dividing rational expressions, remember, you always multiply by the reciprocals. All right, so let's talk about this. So just what I was just talking about. Rational numbers have fractions, rational expressions, fractions where there's a variable of some sort in the denominator. Okay. All right, so let's talk about the domain. The domain is all the numbers that x could be. Domain. What x could be. All right. So in the first problem here, A, x could be anything. There's no problem squaring something. There's no problem multiplying something by 5. So for problem A, we could say all real numbers. So if x was 5, that problem would work. If x was 1,000,000, it would work. If x was negative 1,000,000, it would work. There is a shortcut symbol for all real numbers, and that's similar to how you do the paragraph symbol in English, but it's an R, right, with the 2 lines, the 2 vertical lines. So all real numbers, you could just write that. It means the same thing. All right, for B, you can never, ever, ever divide by 0. That's what we're going to be worried about in this unit. Okay? So in the denominator here, we have an x minus 4. If that was equal to 0, we would have a problem. So we're going to say x minus 4 cannot be 0. If we solve this, we would say x cannot equal 4. And that is our domain, okay, which we can write as this. The domain is x cannot equal 4. That's your answer on part B. On part C, we would say x squared plus 1 cannot equal 0. So x squared cannot equal negative 1. But if we took the square root, you can't take a square root of a negative to come up with a real number. So on this one, we would say all real numbers. Everything's going to work. And lastly, on problem D, we would say x, the denominator, can't equal 0. Nothing to solve there. We're done. Your turn. Try these. All right, so you should have come up with those 4 answers. All right, excluding values from the domain of rational ones, determine what real numbers must be excluded. So we're doing the same thing, just finding the domain here. All right, so on A, we're going to say x squared minus 4 cannot equal 0. So let's solve. X squared cannot equal positive 4. And so x, when we take the square root, cannot equal plus or minus. Don't forget the plus or minus 2. There are 2 numbers that x could not be. That's your domain. All right, so B, x squared minus 5x cannot equal 0. Okay, you need to factor on this one. Pull out the x. We have x minus 5. So we would say x cannot equal 0. X minus 5 cannot equal 0. Both parts. So x cannot equal 0, or by solving this one, positive 5. That's your domain. Okay? Let's try one more. Simplify and state any domain restrictions. So let's factor the numerator. So what multiplies to -1 and adds to -2? X minus 2 and x plus 1. And we can factor the denominator by pulling out a 2 and have an x plus 1. And so we would cancel these out. And so our final answer is x minus 2 over 2. But we do have a restriction. We would say x cannot equal, from right here, even though it cancels out, x still cannot equal -1. That's your answer. All right, so your turn. Give that a shot. Correct answer, x plus 2 over 2, x can't equal 1. All right, simplifying rational expressions. So let's reduce to lowest terms. We're going to factor the numerator. So we're going to say what multiplies to -1? AC is -1, and your b is -6. So we're going to go with a negative, I'm sorry, flip that. Your b is -1, and your AC is -6. Those are -3 and +2. And your denominator, what multiplies to -2 and adds to 1, and we will say x plus 2, x minus 1. Those cancel, so your final answer is x minus 3 over x minus 1. X cannot equal -2 or +1. All right, your turn. Correct answer, x minus 2 over x minus 1. X cannot be -3 or 1. Okay. All right, so what happens if they're not in the same order? A little tricky. So the top can be factored as x plus or minus 2. In the denominator, we're going to flip this around and write it as -x plus 2. You can always pull out a -1, and that would flip the order to x minus 2. And that helps us because in the numerator we have an x plus 2 and an x minus 2. And now we can cancel, and we would say x plus 2 over -1, which is just -x minus 2. X cannot equal +2. All right, your turn. Give it a shot. Answer, -x plus 5. You could have written that as -x minus 5 as well. X cannot equal 5. All right, so let's do some multiplying and dividing. So here's your steps. Take a second to write these down if you want all the steps. I'll be going through all these as we go. And dividing, almost the same, but we have 2 extra steps for dividing. All right, so the key on this as we went into the steps is we're going to factor completely first. Factor completely first. So 3x plus 1 is already factored. Over the denominator, you can pull out a 4x, and you're left with an x plus 1. Times, we can pull out an x, and we're left with x squared plus 3x plus 2. And that actually, so x squared 3x plus 2, after we keep going here and pull out a 3x plus 1, that will be 3x plus 1 over 4x, x plus 1, times x. This factors to x plus 2 and x plus 1. Over the 3 and the x plus 1. Okay, cancel if you can. Cancel, cancel. And nothing else to cancel. So our final answer is going to be x, 3x plus 1, x plus 2, over 12x, x plus 1. X cannot equal -1 from both of these. Don't forget about this one here. X can also not equal 0. Give it a shot. Factor first, then cancel. X plus 3 over 12. X cannot be 0, 1, or -1/2. All right, so we'll do some dividing. So we'll factor first. X minus 2 and x plus 2 over x. And before we multiply by the reciprocal, let's factor. So we can pull out a 3x, and we're left with x squared minus 4. And we have over a 5x cubed. So really quickly here, we're going to say that x cannot equal 0 because of this and this, all the denominators. But now let's multiply by the reciprocal, x minus 2, x plus 2, over x, times, so flip this over, 5x cubed. The denominator is 3x, and this can be factored further, x plus 2 and x minus 2. So we get 2 more restrictions. It also cannot equal plus or minus 2, right? And then let's go to see if we can cancel some things. I see a minus 2. I see a plus 2. And then we have 5x cubed over 3x squared. That can be reduced as well, and you're ending up with 5x over 3. X cannot equal 0 or plus or minus 2. Your turn. Correct answer, 7x squared over 2. X can't be plus or minus 3 or 0. All right, that will do it. Any questions, make sure you're asking in class.